Okay, so here we have the ambiguous case, SSA, which stands for side-side angle. So first, ambiguous case. It occurs when using the law of sines to determine missing sides of a triangle when you are given two sides and an angle opposite of one of those sides. This makes it SSA, or side-side angle, which is basically when you have a triangle like this, and you have angle A, and then side A, B, trying to figure out C, B, and angle C. So for this, if we are given side-side angle, there is three possible solutions. That makes 0 solutions, 1 solution, or 2 solutions. And to get those solutions, you figure out right now. So when you have an obtuse angle, which is when it would be like that, be at 90 degrees, you would have no solution or 1 solution. So if the given angle is obtuse and the coordinating side is less than or equal to the second side given, there's no solution. So the triangle would look like, so this is the angle given, we'll call that A, and we'll say this is side B. Angle A would be less than, which would be like right there. And so it wouldn't make a full triangle. You wouldn't get that part right there. So, and then if the given angle is obtuse and the coordinating side is greater than the second side, it would look like this. So that's the, say this is the angle again, this is B, and then it go all the way across. Of course, that's not a great triangle, but. All right, so now we have an acute angle with the ambiguous case. So first, the condition would be A is less than H, and H is the height, so that would be H right there. And of course, since A is less than H, it wouldn't be able to reach all the way down, which you would need right there. And so that means that no triangle would be possible for it. Second, we have A is equal to H, and H would also be A here. So, of course, one right triangle can be formed. Third, we have H. I'll just draw H across again. And H is less than A, which is less than C. So C is the biggest one, and then H is smallest, A in the middle. You see here, I kind of messed up that height a little bit. You see H is still less than. So, and then fourth, the final one, is A is greater than or equal to C. As you can see, they're about the same right here, and H, of course, is in the middle. And so that would make one triangle possible. And also for this one, for this, it would be the two triangles would be possible. Okay, and that's about it with the notes, and let's get into some problems.
The first example is an easy example. So we're given the angle, so we draw this. We're given angle A, which is obtuse, 144. And then we're given side C, which is 24. And then given side A, which is only 4. And for obtuse angles, there can only be two solutions. It could be no solution or one solution. And since the given side with the angle is less than the second side, there's no solution because it can't reach, which is all this space that's left. This example is the harder one. So we have to draw it out first. This side is, or angle is 63 degrees, so we know it's acute. And then side B is 18, and then side A is 17. But we have to figure out what the height is. And that, so if this is greater than the height, it can either go like that or like that. So to find the height, we have to do sine of 63 degrees is equal to the height over 18. And then to get the height, you have to do 18 times the sine of 63, which would be 16.0. So we know the height is 16. So side A is greater than the height. So there's two possible solutions. And then, so the law of sine states that the sine of one angle over its side is equal to the sine of another angle over its side. So if we do sine of 63 degrees over 17 equals the sine of B over 18, and then we have to solve this, so it'd be sine of B equals 18 times the sine of 63 over 17, which would be sine of B equals 0.9434. And then you have to take that inverse sine of this and plug that into the calculator, which would be the angle B is 70.6. So we have angle A, which is 63 degrees, angle B, which is 70.6. And then to find angle C, you subtract them from 180, which would be, to find angle C, you would subtract 180 minus angle A and angle B, which comes out to be 46.4 degrees. So we have all the angles, so we have to find the third side, which is C. And then, so we could go back to the law of sines. So we could go sine of 63 over 17 is equal to sine of 46.4 degrees over C. And then to solve that, it would be C equals 17 sine of 46.4 divided by sine of 63, which comes out to be 13.8. So we have side A, which is 17, side B, which is 18, and then side C, which is 13.8. And then angle A is 63 degrees. Angle B is 70.6 degrees. And angle C is 46.4 degrees. And that would be for the first triangle, which is this 63, 18, 17, 13.8, 70.6, and then 46.4. So that's one possible solution. And then we get to solve to find the second triangle, which is like that. To find the second triangle, you have to fill out the first one. So 70.6 degrees is there, but you have to draw in the second one, which is there. And then since this side is 17 and these two are equal, so this side would be 17 and the triangle is isosceles. So this angle right here would also be 70.6 degrees. And then since you're trying to find this triangle right there, these two, this angle and this angle are supplementary. So this right here would be 109.4 degrees. And then since you already have this one, that's 63. And then to find the third angle, you just subtract both of them from 180. Fucking hell, bro. To find a third angle, you subtract 180 from the two other angles that you have. So this would be 7.6. And then since you have this side, which is 17, this side, which is 18, you use the law of sines again. So it'd be 17. To find the third side, you do sine of 63 over 17 is equal to the sine of 7.6 over C. And then to solve for C, it'd be C equals 17 sine of 7.6 divided by sine of 63. So the third side would be 2.5. So the measurements would be our side A is 17, angle A is 63, side B is 18, and the angle is 109.4, and side C is 2.5, and the angle is 7.6 degrees. And those are the measurements for the second triangle.